In this video, you are going to learn the second algorithm for solving minimum spanning tree problem due to Prim's algorithm. Like Kruskal's algorithm, Prim's algorithm also an extension of generic minimum spanning tree method that we discussed in the previous video. The difference is that how we are going to pick a cut. In Prim's algorithm, we always consider a cut in a way that all the edges leaving the vertices whose edges in MST list incident with crosses the cut. For example, consider the below diagram. Now here, I have used black color to indicate the edges which are currently at MST list. And for this state, there are 3 vertices which these 2 edges incident with. Hence, we are going to consider a cut which will cross by all the edges leaving these 3 vertices, so our cut will look like this. Now here I have not considered the edge between these 2 vertices. Let me highlight it for you. I haven't considered the edge between these 2 vertices because both the end vertices for this edge is currently incident by edges in MST, so there's no need to consider this edge. Okay, let's see an example of this methodology. Here we are going to find the MST for this graph using Prim's algorithm. Now usually for Prim's algorithm we are going to have a source vertex, so we can consider the edges leaving that source vertex in the first iteration. So for this graph we are considering vertex A as our source vertex. Now we have to find a cut which crosses all the edges leaving this A vertex, so our cut will look like this. Now for this cut, light edge is the edge between A and B vertex, so we are going to add that edge to our MST list. Okay, let's move on to the second iteration. Now for second iteration, both A and B vertices incident by edge in MST. So we have to pick a cut which will crosses all the edges which leaves both A and B vertices, so our cut will look like this. Now the light edge for this cut is the edge between B and C vertices, so we are going to add that edge to our MST list as well. For third iteration, A, B and C vertices incident by the edges in the MST list. So we have to pick a cut which crosses the edges leaving A, B and C vertices. So our cut for this iteration will look like this. Now the light edge for this cut is the edge between C and I vertices, so we are going to add that edge to our MST list as well. So currently our MST list has 3 edges, edge between A and B vertex, edge between B and C vertex and edge between C and I vertex. For the fourth iteration, we have to pick a cut which crosses the edges leaving A, B, C and I vertices. So our cut will look like this. And the light edge for this cut is edge between C and F vertex, so we are going to add that edge to MST list as well. For the fifth iteration, we have to pick a cut which crosses the edges leaving A, B, C, I and F vertices. So our cut will look like this. Light edge for this cut is the edge between G and F vertices, so we are going to add that edge to our MST list as well. In same way, we can pick a cut for 6th iteration in this way. So light edge for this cut is the edge between H and G vertices, so we are going to add that edge to our MST list as well. For the 7th iteration, our cut will look like this. So we are going to add light edge or the edge between C and D vertices to our MST list as well. For the 8th iteration, our cut will look like this, and the light edge for this cut is the edge between D and E vertices, so we are going to add that edge to our MST list as well. Now after this iteration, all the vertices in our graph is connected by edges in MST, which means our MST is completed, so final minimum spanning tree for this graph is look like this. Okay, that's it for this video. In the next video, we will look at pseudocode for this methodology and how to implement that pseudocode with C++. Thank you.